Hi everyone. Today let's look at a classic problem. Longest palindromic substring. Opening. We are given a single string made of letters, and we need to find the longest palindromic substring inside it. A palindrome is a sequence that reads the same forwards and backwards, like the word bab or the word aba. The substring must be contiguous, a clean slice of the original string, and we want the longest such slice. When several answers have the same length, any one of them counts as correct. Naive approach. A simple solution checks every possible substring and tests whether each one is a palindrome. A string has roughly the square of its length in substrings, and testing one substring takes time proportional to its length. Together that gives a cubic running time, which becomes far too slow as the string grows. We can do much better by using the symmetry of a palindrome directly instead of testing slices blindly. Core idea. The key insight is that every palindrome mirrors around a center. That center can sit on a single character, giving an odd-length palindrome like ABBA, or it can sit between two neighboring characters, giving an even-length palindrome like BB. So instead of testing every substring, we walk through the string dot, treat each position as a potential center, and expand outward to the left and right as long as the two sides still match. At each position, we try both an odd center and an even center, and we keep track of the longest palindrome we have seen so far. Key details. A few details keep this clean. First, at every index we run the expansion twice, once with both hands on the same character to grow an odd palindrome, and once with the hands on neighboring characters to grow an even palindrome. Second, the expansion keeps stepping outward until the two characters differ, or until one hand walks off the end of the string and then it stops. Third, the length we record is the distance between the two hands after they have stepped one step too far, which neatly counts the matched characters. Fourth, whenever a center produces a longer palindrome than the current best, we recompute the start and end of the best window from the center index and the new length. Fifth, we only update on a strictly longer length, so when two palindromes tie, the later center replaces the earlier one, although either answer is correct. Walkthrough. Let's trace the first example. We are given the string babad, 5 letters long, and we want the longest palindromic substring inside it. We set up by noting that a single character is always a palindrome of length 1, so the best window can safely start as just the first character, B, covering index 0 only. From here we will sweep through the string and try every index as a center. The first center is index 0, the character B. We pair it with itself to grow an odd palindrome. There is no character to its left, so the expansion stops right away, and the odd palindrome is just the single character B with length 1. Next, we try an even center at the same index, pairing the character B at index 0 with the character A at index 1. These two characters differ, so there is no even palindrome here, and the even length is 0. We take the longer of the two lengths, which is 1, and compare it against the current best span of 0. 1 is greater than 0, so this counts as an improvement. We recompute the start and end of the best window from the center and the new length, and the best stays as the single character B. We move to the next center, index 1, which is the character A. The best palindrome found so far is still just B, with length 1. At index 1, we again grow an odd palindrome, starting from the character A and stepping outward. The character to its left at index 0 is B, and the character to its right at index 2 is also B. They match. We step outward again, but now we have walked off the left end of the string, so we stop. The matched palindrome is Bab with length 3. Now we try an even center at index 1, pairing the character A at index 1 with the character B at index 2. These two differ, so the even palindrome here has length 0. The longer of the two lengths is 3, which is greater than the current best span of 0. So we update. Recomputing from the center index 1 and the length 3 gives a start of 0 and an end of 2. The best palindrome is now BAB, covering the first 3 letters. We move to the next center, index 2, the character B. The best palindrome so far is BAB, with length 3. At index 2, we grow an odd palindrome from the character B. The character to its left at index 1 is A, and the character to its right at index 3 is also A. They match. Stepping outward again would walk off the matched region, so we stop. The matched palindrome is ABA, with length 3. We try an even center at index 2, pairing the character B at index 2 with the character A at index 3. They differ, so the even length is 0. The longer of the 2 lengths is 3. The current best window starts at 0 and ends at 2, so the gap between its ends is 2. Since 3 is greater than 2, this new palindrome counts as an improvement, even though it is the same length as the previous best. Recomputing from the center index 2 and the length 3 gives a start of 1 and an end of 3. The best palindrome is now A. We move to index 3, the character A. The odd palindrome here is just the single character A with length 1, and the even center mismatches, giving length 0. The longer length is 1, which does not beat the current best gap of 2, so we leave the best window unchanged. The last center is index 4, the character D. Its odd palindrome is just the single character D with length 1, and its even center would pair with a position past the end of the string, giving length 0. Again, the longer length is 1, not greater than 2, so the best window stays as it is. Every index has now been tried as a center. We hand back the best window from index 1 through index 3, which is the substring ABA. Notice that BAB and ABA are equally long, both with length 3. The algorithm picks ABA because it only updates on a strictly longer length, so the later center wins the tie. Both are perfectly valid answers, so the result is correct. Complexity. The running time is quadratic in the length of the string. We try each index as a center, so there is a linear number of centers, and at each center, the expansion may walk across up to about half the string. Multiplying these two together gives a quadratic total. The extra space we use is constant, since we store only a handful of variables and never copy the string. Summary. The longest palindromic substring falls out of a simple symmetry. Every palindrome has a center, so we just expand around every possible center and keep the longest result. The ideas to remember are these. Try 2 centers at each index, 1 odd and 1 even. Expand outward only as long as the 2 sides match. We compute the best window from the center and the length whenever you find something longer, and accept that ties can go either way. Thank you all, and see you next time.